All right, so today your guys' lesson is going to be on the law of cosines. So the law of cosines, you can only use them with non-right triangles. In order for it to be worth your while, you want to use it with oblique triangles, which are non-right. So given this triangle, it's definitely a non-right. I've got these sides. We've got A, B, and C. Those are the corners, which are for the angles. And then we have the opposite sides, C, and B. We have these corresponding sides. And we have three types of this law of cosines formula. So the three formulas are based off of what side or what angle is missing. So say we are missing side A. Our formula is going to be b squared plus c squared equals 2bc cosine of the angle A. That's the angle that goes with it. Now we also have, if b is missing, so we have the side b squared equals a squared plus c squared minus 2 times a times c, all times that cosine of that angle B. Then the last one is if we have c squared. So that's if our side c is missing, we have the side a squared and the side b squared minus 2ab cosine of c. Now, we use these to find the missing sides or the missing angle. If you notice, I have all my lowercase letters are my sides, and my capitalized or uppercase letters are my angles. So these angles that are connected to my cosine A, what is in that cosine A piece is always going to be what is going with that missing side. So let's continue with the video. So just got to move it down. So let's do an example so that you guys can visually see what we are doing when we're finding these missing sides. We're going to start with a missing side, and then we'll end up doing a missing angle in the next piece. So, given this triangle, I have my side lengths of 7 and 9, and I have an angle between them that's 100 degrees. Now, typically, when you use the law of cosines, you have two sides, and that angle that's between them is what you are solving. Just be aware that when you see a setup like that, you are going to use the law of cosines instead of the law of sines. So we have the sides A, B, and C, and we need to find our side A that corresponds with our angle A. So we are going to be using our top formula. However, with this top formula, if you look, we've got the b squared and the c squared. These are interchangeable. So I'm going to end up doing my c squared plus b squared. It's the same thing because we've got this addition property and they have the same pieces that are there. So let's jump into that. So I have my a squared equals my 7 squared, which is my c, my 9 squared, which is my b, minus 2 times 7 and 9, which that's c and b, cosine of my angle 100 degrees. That's that angle that's in between them. That's my given. So, the important thing is to remember that your calculator is in degrees. You need to make sure you have it in degrees and not radians. So now I'm going to put the pieces together. I've got 49 and 81 minus that right there is 126 times the cosine of 100 degrees. An important thing to remember is that this negative 126 is connected to my cosine of 100 degrees. So you cannot take this 81 and subtract 126. The 126 is multiplied to the cosine 100, so when you do your calculator work, that must go first because they are connected to each other. So now I've got my a squared equals, put those two pieces together, that is 130 minus my 126 times the cosine of 100 degrees. So putting this into my calculator, make sure once again it's in degrees and not radians. So I have 130 minus a negative 21.9. So we have a negative minus a negative, so we're actually going to add this piece. So we have a squared equals 130 plus 21.9. So that gives us 151.9. We are going to have the square root of that, and our a value is 12.32 units. I did round it on that piece to the nearest hundredth.